In today's video, we will be solving questions 6, 7, 8, and 9 from the new syllabus Mathematics Book 2, Exercise 3A. These questions are based on the expansion and simplification of algebraic expressions. Before solving these questions, I want to quickly remind everyone watching this video that in addition and subtraction of algebraic expressions, we look for like terms, because we can only add or subtract like terms. Like terms are terms with the same variable and the same power. On the other hand, in multiplication and division, we don't look for like terms, because we can multiply or divide like or unlike terms. Another important point related to the simplification of algebraic expressions is that we can simplify algebraic expressions using the distributive property. Remember, when we don't have an exponent attached to a variable, there is an understood exponent of 1. Anything to the power of 1 is just itself. Also, when we don't have a coefficient in front of a variable, or just like the negative sign in front of the parentheses, there is an understood coefficient of 1. Now let's start solving these questions. Question 6 states to expand and simplify each of the following expressions. The first part from this question is positive 7, and then in parentheses positive 2a positive 1, negative 4, and then in parentheses positive 8a positive 3. I'm going to take that 7 on the outside of the parentheses and distribute it to the positive 2a and to the positive 1. So we have 7 times 2a, positive 7 times positive 1. Then we can distribute the negative 4 to the positive 8a and to the positive 3. We have negative 4 times positive 8a, negative 4 times positive 3. Positive 7 times positive 2a is positive 14a, positive 7 times 1 is positive 7, negative 4 times positive 8a is negative 32a, and negative 4 times positive 3 is negative 12. Now we look for like terms. We have positive 14a and negative 32a. Combining them gives us negative 18a. Next we have positive 7 and negative 12, which gives us negative 5. Negative 18a, negative 5 is our simplified expression because they are unlike terms and we can't combine those two terms. Moving on to number 2, we have positive 3 and then in parentheses positive 2b and negative 1, negative 2 and then in parentheses positive 5b, negative 3. Now positive 2b and negative 1 are unlike terms, so we can't add or subtract those terms. What we can do is use the distributive property to remove the parentheses. Let's distribute positive 3 to the positive 2b and to the negative 1. Then we can distribute the negative 2 to the positive 5b and to the negative 3. We have positive 3 times positive 2b, positive 3 times negative 1, negative 2 times positive 5b, negative 2 times negative 3. Positive 3 times positive 2b is positive 6b. Positive 3 times negative 1 is negative 3. Negative 2 times positive 5b is negative 10b. Negative 2 times a negative 3 is positive 6. Now we look for like terms. The reason we combine like terms is to simplify the algebraic expression. We have positive 6b and negative 10b. Combining them gives us negative 4b. Next we have negative 3 and positive 6. Combining them gives us positive 3. Negative 4b, positive 3 is our simplified expression because we can't add or subtract those two terms further. Moving on to number 3, we have positive 3c and then in parentheses positive 5, positive c, negative 2c and then in parentheses positive 3c, negative 7. I'm going to simplify this algebraic expression using the distributive property. I'm going to take that positive 3c on the outside of the parentheses and distribute it to the positive 5 and to the positive c. And then we can distribute the negative 2c to the positive 3c and to the negative 7. That gives us positive 3c times positive 5, positive 3c times positive c, negative 2c times positive 3c, negative 2c times negative 7. Now positive 3c times 5 is 15c. Positive 3c times c is positive 3c squared. Negative 2c times 3c is negative 6c squared. Negative 2c times negative 7 is positive 14c. Now we look for like terms. We have positive 3c squared, negative 6c squared. Combining them gives us negative 3c squared. Next we have positive 15c, positive 14c. Combining them gives us positive 29c. Therefore, negative 3c squared, positive 29c is our simplified expression. Moving on to number 4, we have positive 2d and then in parentheses positive 3d negative 5, negative d and then in parentheses positive 2 negative d. Let's start by using the distributive property to remove any parentheses and then we can look to combine like terms. Let's distribute this positive 2d to the positive 3d and then to the negative 5. Then we can distribute the negative d to the positive 2 and then to the negative d. So we have positive 2d times positive 3d, positive 2d times negative 5, negative d times positive 2, negative d times negative d. Positive 2d times positive 3d is positive 6d squared. Positive 2d times negative 5 is negative 10d. Negative d times positive 2 is negative 2d. Negative d times negative d is positive d squared. Now for this expression, I'm going to rewrite it with all of the like terms next to each other. This is a strategy we can use to organize the expression and make combining like terms a little simpler. Since all of the like terms will be right next to each other, so let's identify any like terms in this expression. We have positive 6d squared, positive d squared, negative 10d, and negative 2d. Now positive 6d squared, positive d squared gives us 7d squared, and negative 10d, negative 2d gives us negative 12d. Now positive 7d squared and negative 12d is our simplified expression. Moving on to number 5, we have negative f and then in parentheses positive 9, negative 2f, positive 4f and then in parentheses positive f negative 8. Using the distributive property, I'm going to distribute the negative f to the positive 9 and then to the negative 2f. Then we can distribute the positive 4f to the positive f and then to the negative 8. We have negative f times positive 9, negative f times negative 2f, positive 4f times positive f, and positive 4f times negative 8. Negative f times 9 is negative 9f. Negative f times negative 2f is positive 2f squared. Positive 4f times f is positive 4f squared. Positive 4f times negative 8 is negative 32f. Now for this expression, I am going to rewrite it with all of the like terms next to each other. This is a strategy we can use to organize the expression and make combining like terms a little simpler. Since all of the like terms will be right next to each other, so let's identify any like terms in this expression. We have positive 2f squared, positive 4f squared, and negative f, negative 32f. Positive 2f squared, positive 4f squared gives us positive 6f squared. Negative 9f, negative 32f gives us negative 41f. This is the simplified expression because we can't add or subtract these two terms, and they are unlike terms. Moving on to number 6, we have negative 2h and then in parentheses positive 3, positive 4h, negative 5h and then in parentheses positive h negative 1. To simplify the given algebraic expression, I'll distribute the negative 2h to the positive 3 and then to the positive 4h. And then we can distribute the negative 5h to the positive h and then to the negative 1. We have negative 2h times positive 3, negative 2h times positive 4h, negative 5h times positive h, negative 5h times negative 1. Negative 2h times positive 3 is negative 6h. Negative 2h times positive 4h is negative 8h squared. Negative 5h times positive h is negative 5h squared. Negative 5h times negative 1 is positive 5h. To find like terms in this expression, I'm going to arrange the expression by putting all of the like terms right next to each other. Now let's identify any like terms in this expression. We have negative 8h squared, negative 5h squared, negative 6h and positive 5h. Negative 8h squared, negative 5h squared is negative 13h squared. Negative 6h, positive 5h is negative h, which is our simplified algebraic expression. Let's solve some other algebraic expressions using the distributive property. Question 7 states, expand each of the following expressions. Moving on to number 1, we have in parentheses positive a, positive 1, and then in parentheses positive a, negative 9. To simplify these two expressions, I'm going to multiply positive a, positive 1 to the positive a, negative 9. We have positive a times positive a, negative 9, positive 1 times positive a, negative 9. Now using the distributive property, I'm going to distribute the positive a to the positive a and then to the negative 9. And then we can distribute the positive 1 to the positive a and then to the negative 9. We have a times a squared, a times negative 9, negative 9a. Positive 1 times a is positive a, and positive 1 times negative 9, negative 9. Now we look for like terms. We have negative 9a and positive a. Combining them gives us negative 8a. So positive a squared, negative 8a, negative 9 is our simplified expression because they are unlike terms. Moving on to number 2, we have positive b, negative 2, and then in parentheses positive b, positive 7. Let's distribute the positive b to the positive b plus 7 and the negative 2 to the positive b plus 7. We have positive b times positive b plus 7, negative 2 times positive b plus 7. Now I will distribute the positive b to the positive b and to the positive 7. Then we can distribute the negative 2 to the positive b and to the positive 7. We have b times b, b square, positive b times positive 7, positive 7b, negative 2 times b, negative 2b, negative 2 times positive 7, negative 14. Now we have only two like terms in this expression, positive 7b and negative 2b, which gives us positive 5b. Therefore, positive b squared, positive 5b, negative 14 is our simplified expression because we can't add or subtract those terms. Moving on to number 3, we have positive c negative 5 times positive c negative 6. Let's distribute the positive c to the positive c negative 6 and negative 5 to the positive c negative 6. We have c into c negative 6, negative 5 into positive c negative 6. Let's distribute the positive c to the positive c and to the negative 6. And then we can distribute the negative 5 to the positive c and to the negative 6. We have c times c, positive c squared, c times negative 6, negative 6c, negative 5 times c, negative 5c, negative 5 times negative 6 is positive 30. Now we look for like terms. We have only two like terms in this expression, negative 6c, negative 5c. Combining them gives us negative 11c. So positive c squared, negative 11c, positive 30 is our simplified expression. Now, moving on to number 4, we have positive 3d positive 1 times positive 5 negative 2d. By applying the distributive property, we can multiply the terms in the first parentheses, positive 3d positive 1, by the terms in the second parentheses, positive 5 negative 2d. We have positive 3d times positive 5 negative 2d, positive 1 times positive 5 negative 2d. Now let's distribute the positive 3d to the positive 5 and to the negative 2d. And then we can distribute the positive 1 to the positive 5 and to the negative 2d. We have 3d times 5, 15d, 3d times negative 2d, negative 6d squared, positive 1 times 5, positive 5, and positive 1 times negative 2d, negative 2d. Now we look for like terms. Since the only like terms in this expression are positive 15d and negative 2d, combining them gives us positive 13d. So, negative 6d squared, positive 13d, positive 5 is our simplified expression because we can't add or subtract those terms. Moving on to number 5, we have in parentheses positive 1 negative f, and then in parentheses positive 7f positive 6. To remove the first pair of parentheses, I'll multiply the positive 1 to the algebraic expression positive 7f positive 6 and negative f to the expression positive 7f positive 6. That gives us positive 1 times positive 7f positive 6 and negative f times positive 7f positive 6. Now let's distribute the positive 1 to the positive 7f and to the positive 6. And then we can distribute the negative f to the positive 7f and to the positive 6. We have 1 times positive 7f, positive 7f, 1 times positive 6, positive 6, negative f times positive 7f, negative 7f square, negative f times positive 6, negative 6f. To find like terms in this expression, I'm going to arrange the expression by putting all of the like terms right next to each other. We have negative 7f square, positive 7f, negative 6f, positive 6. Now let's identify any like terms in this expression. We have positive 7f, negative 6f. Combining them gives us positive f. Our simplified expression is negative 7f square, positive f, positive 6, because we can't add or subtract those terms. Let's jump into number 6, where we have in parentheses positive 4 negative 3h and then in parentheses positive 10 negative 9h. To simplify the given expression, I will remove the first set of parentheses. To do this, let's multiply positive 4 to the expression within parentheses positive 10 negative 9h and negative 3h to the expression within parentheses positive 10 negative 9h. We have 4 times 10 negative 9h, negative 3h times 10 negative 9h. Now let's distribute the positive 4 to the positive 10 and to the negative 9h. And then we can distribute the negative 3h to the positive 10 and to the negative 9h. That gives us 4 times 10 is 40. 4 times negative 9h is negative 36h. Negative 3h times 10 is negative 30h. Negative 3h times negative 9h is positive 27h square. Now to identify the like terms, I'm going to arrange the expression by putting all of the like terms right next to each other. We have positive 27h square, negative 36h, negative 30h, positive 40. Negative 36h, negative 30h gives us negative 66h. So our simplified expression is positive 27h square, negative 66h, positive 40, because we can't add or subtract those terms further. Question number 8 involves simplifying other algebraic expressions using the distributive property and combining like terms. Let's start with the first expression. We have positive 5, positive, and then in parentheses positive x positive 1 times positive x positive 3. First, I'll simplify the terms in the parentheses by multiplying positive x times positive x positive 3 and positive 1 times positive x positive 3. This gives us positive 5, positive x times positive x plus 3, positive 1 times positive x plus 3. Next, distribute positive x to the positive x and to the positive 3. And then we can distribute positive 1 to the positive x and to the positive 3. That gives us positive 5. Positive x times positive x squared, positive x times positive 3, positive 3x, positive 1 times x, positive x, positive 1 times 3, positive 3. Now to identify like terms, I'm going to arrange the expression by putting all of the like terms right next to each other. We have positive x squared, positive 3x, positive x, positive 5, and positive 3. Now the only like terms in this expression are positive 3x, positive x, and the constant terms positive 5 and positive 3. Positive 3x positive x gives us positive 4x. Positive 5 positive 3 gives us positive 8. Now x squared positive 4x positive 8 is our simplified algebraic expression because we can't add or subtract those terms. Moving on to number 2, where we have positive 3x positive x positive 7 times positive 2x negative 1. Let's distribute positive x to the positive 2x negative 1 and positive 7 to the positive 2x negative 1. We have positive 3x, positive x times positive 2x negative 1, positive 7 times positive 2x negative 1. Now let's distribute positive x to the positive 2x and to the negative 1. And then we can distribute positive 7 to the positive 2x and to the negative 1. We have positive 3x, positive x times positive 2x is positive 2x squared. Positive x times negative 1 is negative x. Positive 7 times positive 2x is positive 14x, and positive 7 times negative 1 is negative 7. To find like terms in this expression, I'm going to arrange the expression by putting all of the like terms right next to each other. We have positive 2x squared, positive 3x, negative x, positive 14x, negative 7. Positive 3x negative x is positive 2x. Positive 2x and positive 14x is positive 16x. Now positive 2x squared, positive 16x, negative 7 is our simplified expression. Moving on to number 3, we have positive 3x positive 2 times positive x negative 9. Positive 2x times positive 4x positive 1. To simplify the first two expressions in parentheses, I'll multiply the positive 3x by the expression positive x negative 9 and the positive 2 by the expression positive x negative 9. Then we can distribute the positive 2x to the positive 4x and to the positive 1. We have positive 3x times positive x negative 9, positive 2 times positive x negative 9, and then positive 2x times 4x, positive 2x times positive 1. Now I will distribute positive 3x to the positive x and to the negative 9. And then we can distribute positive 2 to the positive x and to the negative 9. We have positive 3x times x, positive 3x squared, positive 3x times negative 9, negative 27x. Positive 2 times x is positive 2x. Positive 2 times negative 9 is negative 18. Same as positive 2x times positive 4x is positive 8x squared, and positive 2x times 1 is positive 2x. Now to find like terms in this expression, I'm going to arrange the expression by putting all of the like terms right next to each other. We have positive 3x squared, positive 8x squared, negative 27x, positive 2x, positive 2x, negative 18, which is a constant term. Now positive 3x squared, positive 8x squared is positive 11x squared. Positive 2x is positive 4x. Now negative 27x, positive 4x is negative 23x. Therefore, positive 11x squared, negative 23x, negative 18 is our simplified expression. Moving on to number 4, we have positive x negative 3 times positive x negative 8, positive x negative 4 times positive 2x positive 9. Now there are 4 expressions, 2 on the left side of the positive sign and 2 on the right side. Let's eliminate the parentheses by using the distributive property. I'll distribute the positive x to the expression positive x negative 9 and the negative 3 to the expression positive x negative 9. And then we can distribute positive x to the expression positive 2x positive 9 and negative 4 to the expression positive 2x positive 9. We have positive x times positive x negative 9, negative 3 times positive x negative 8, positive x times positive 2x positive 9, and negative 4 times positive 2x positive 9. Now to remove the parentheses, let's distribute the positive x to the positive x and to the negative 8, the negative 3 to the positive x and to the negative 8, the positive x to the positive 2x and to the positive 9, negative 4 to the positive 2x and to the positive 9. We have x times x, x raised to the power 2, x times negative 8, negative 8x, negative 3 times x, negative 3x, negative 3 times negative 8, positive 24, positive x times positive 2x, positive 2x squared, positive x times positive 9, positive 9x, negative 4 times 2x is negative 8x, negative 4 times positive 9 is negative 36. Now to find like terms in this expression, I'm going to arrange the expression by putting all of the like terms right next to each other. We have positive x squared, positive 2x squared, negative 8x, negative 3x, negative 8x, positive 9x, positive 24, and negative 36. Now positive x squared, positive 2x squared gives us positive 3x squared. Now negative 8x, negative 3x, negative 8x gives us negative 19x. Positive 24, negative 36 is negative 12. Next, negative 19x, positive 9x gives us negative 10x. Therefore, positive 3x squared, negative 10x, negative 12 is our simplified expression because we can't add or subtract those terms. Let's solve some other algebraic expressions using the distributive property. These questions are from Book 2 Advanced Level. The statement of the question is as follows. Expand and simplify each of the following expressions. Moving on to number 1, we have positive 4x squared, negative, and then in parentheses, positive 3x negative 4 times positive 2x positive 1. To simplify the expression, I'll multiply the expression in the second parentheses by each term in the first parentheses. Let's not forget to include the square brackets for the expansion of positive 3x negative 4 and positive 2x positive 1. We have positive 3x times positive 2x positive 1 negative 4 times positive 2x positive 1. Now using the distributive property, I'll distribute the positive 3x to the positive 2x and to the positive 1. And then we can distribute the negative 4 to the positive 2x and to the positive 1. We have 3x times 2x, positive 6x squared, 3x times positive 1, positive 3x, negative 4 times positive 2x, negative 8x, negative 4 times positive 1, negative 4. Since we have negative sign before parentheses, I'll multiply the negative sign by each term in the parentheses to get negative of expression. We have negative times positive 6x squared, negative 6x squared, negative times positive 3x, negative 3x, negative times negative 8x, positive 8x, and negative times negative 4, positive 4. Positive 4x squared, negative 6x squared gives us negative 2x squared. Negative 3x, positive 8x gives us positive 5x. Positive 4 as it is, which is our simplified algebraic expression. Moving on to number 2, we have positive 2x and then in parentheses positive x negative 6, negative, and then in parentheses positive 2x positive 5 times positive 7 negative x. We are going to remove the parentheses. So I'll take that positive 2x on the outside of the parentheses and distribute it to the positive x and to the negative 6. Next, I will multiply the expression in the second parentheses by each term in the first parentheses. Do not forget to include the square brackets for the expansion of positive 2x positive 5 and positive 7 negative x. We have positive 2x times x, positive 2x squared, positive 2x times negative 6, negative 12x, positive 2x times 7 negative x, and positive 5 times 7 negative x. For further simplification, I'm going to distribute the positive 2x to the positive 7 and to the negative x. And then we can distribute the positive 5 to the positive 7 and to the negative x. We have positive 2x times 7, positive 14x, positive 2x times negative x, negative 2x squared, positive 5 times 7, positive 35, and positive 5 times negative x, negative 5x. Since we have a negative sign before the parentheses, I'll multiply the negative sign by each term in the parentheses to get a negative of expression. We have negative times positive 14x, negative 14x, negative times negative 2x squared, positive 2x squared, negative times positive 35, negative 35, and negative times a negative 5x, positive 5x. Now for this expression, I'm going to rewrite it with all of the like terms next to each other. This is a strategy we can use to organize the expression and make combining like terms a little simpler, since all of the like terms are right next to each other. So let's identify any like terms in this expression. We have positive 2x squared, positive 2x squared, which is 4x squared, negative 12x, negative 14x is negative 26x, positive 5x as it is, and then negative 35. Next, negative 26x, positive 5x is negative 21x. Now positive 4x squared, negative 21x, negative 35 is our simplified expression because we can't add or subtract those terms. Moving on to number 3, we have positive 4x, negative 3 times positive x, positive 2, negative times positive 3x negative 5 times negative x, negative 9. To simplify the algebraic expression, I'll multiply the expression in the second parenthesis by each term in the first parenthesis. Do not forget to include the square brackets for the expansion of positive 4x negative 3, positive x positive 2, and positive 3x negative 5, negative x negative 9. We have positive 4x times positive x positive 2, negative 3 times positive x positive 2, positive 3x times negative x negative 9, and negative 5 times negative x negative 9. For further simplification, I'll distribute the positive 4x to the positive x and to the positive 2. And then we can distribute the negative 3 to the positive x and to the positive 2. Next, I will distribute positive 3x to the negative x and to the negative 9. And then we can distribute negative 5 to the negative x and to the negative 9. We have positive 4x times x, positive 4x squared, positive 4x times 2, positive 8x, negative 3 times x, negative 3x, and negative 3 times positive 2, negative 6. Positive 3x times negative x, negative 3x squared, positive 3x times negative 9, negative 27x, negative 5 times negative x, positive 5x, negative 5 times positive 9, positive 45. Next, I'll multiply the negative sign in front of the parentheses to get the negative of the expression. We have negative times negative 3x squared, positive 3x squared, negative times negative 27x, positive 27x, negative times positive 5x is negative 5x, and negative times positive 45, negative 45. Next, I'll combine the like terms. We have positive 4x squared, positive 3x squared, positive 8x, positive 27x, negative 3x, negative 5x, and then constant terms negative 6, negative 45. Positive 4x squared, positive 3x squared is positive 7x squared. Positive 8x, positive 27x is positive 35x. Negative 3x, negative 5x is negative 8x. Negative 6, negative 45 is negative 51. Now positive 35x and negative 8x, they are like terms. Combining them gives us positive 27x. So positive 7x squared, positive 27x, negative 51 is our simplified algebraic expression. Moving on to number 4, we have in parentheses positive 2x positive 3 times positive 5x negative 2, negative 2 times positive 5x negative 3 times positive x positive 1. To simplify the algebraic expression, let's multiply the expression in the second parenthesis by each term in the first parenthesis. Do not forget to include the square brackets for the expansion of positive 2x positive 3, positive 5x negative 2, positive 5x negative 3, and positive x positive 1. We have positive 2x times positive 5x negative 2, positive 3 times positive 5x negative 2, and then positive 5x times positive x positive 1, negative 3 times positive x positive 1. Now let's distribute positive 2x to the positive 5x and to the negative 2. And then we can distribute positive 3 to the positive 5x and to the negative 2. Then I will distribute positive 5x to the positive x and to the positive 1. And then negative 3 to the positive x and to the positive 1. We have positive 2x times positive 5x, positive 10x squared, positive 2x times negative 2, negative 4x, positive 3 times positive 5x, positive 15x, and positive 3 times negative 2, negative 6. Now positive 5x times x, positive 5x squared, positive 5x times positive 1, positive 5x, negative 3 times x, negative 3x, and negative 3 times positive 1 is negative 3. Next, I'll multiply the negative 2 in front of the parentheses by each term within the parentheses. We have negative 2 times positive 5x squared, negative 10x squared, negative 2 times positive 5x, negative 10x, negative 2 times negative 3x, positive 6x, and negative 2 times negative 3, positive 6. Next, let's arrange the like terms in this expression. Positive 10x squared, negative 10x squared, negative 4x, negative 10x, positive 15x, positive 6x, and now constant terms, negative 6, positive 6. Positive 10x squared and negative 10x squared will cancel each other out. Same as negative 6 positive 6 is 0. We have negative 4x negative 10x, which is negative 14x, and positive 15x positive 6x is positive 21x. Negative 14x positive 21x gives us positive 7x, which is our simplified algebraic expression.